So I wanted to do some quick example problems here. This is from the Schoology assignment that's called Fourth Momentum Problems, and show you how to do some of these. So this is number 1. Let's get started on doing some of these. By the way, these are done exactly the same way as the ones that we did last week. So the whole idea is that the total amount of momentum is conserved here. So in number 1, we got a 2-kilogram ball coming in at 5.2 meters per second and a 13-kilogram ball. They don't say it in the picture, but let's make it clear. That velocity is 0. It's just at rest there. I could go further and call this velocity 1 and this velocity 2 if I consider this object 1 and this object 2 here. So then this is before, and then afterwards, notice they stick together, and that's going to be important when we go to solve this problem. And they're asking for velocity prime. Now I could call this velocity 1 prime or velocity 2 prime, but they're actually the same. So I'm just going to think of it as there's one new, more massive object there. So when you go to set these up, remember always, without even thinking about it, you got momentum of the system before is equal to momentum of the system afterwards. What does that mean? Well, that is the momentum, let me actually write one more line here, of object 1 before, plus the momentum of object 2 before, but we can see that that's 0 because it's not moving, so I'll just skip that. And I'll just call this the momentum afterwards. I'm going to consider them one object here. So this will be the mass of object 1 times the velocity of object 1 before, and this I'm going to write like this: mass of object 1 plus the mass of object 2, since they're combined, times their velocity afterwards, or velocity prime. And so that's what we're actually going to solve here. So when we go to plug these in, we can see we got 2 kilograms. We're going 5.2 meters per second. I'm going to go ahead and solve for that because you can do that in your head. You're going to get 10.4 kilogram meters per second of momentum before for the whole system. That means that's going to be the total momentum of the system afterwards. So now let's plug in for this. We know we have a combined mass of 2 kilograms and 13 kilograms. So overall we have 15 kilograms moving. So at what speed must it be moving to get 10.4? So if you solve for that velocity prime, you get, and by the way, it says on the instructions, don't miss this, that everything's to 2 sig figs. So you get like 0.693, blah, 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 blah. So let's just cut it off at 0.69 meters per second. And by the way, it would be going to the right. Overall, in the beginning, our momentum was to the right. That means overall, in the end, our momentum has to be to the right. So let's go on to the next one here. Now I'm skipping up to number 4 here. So on number 4, we've got a 10-kilogram ball going 6 meters per second, a 3-kilogram ball going to the right also at 3 meters per second. And then afterwards, they tell us that the 3-kilogram ball is now, after the collision, going 9 meters per second. And so what's the velocity of the 10-kilogram ball? So let's set this up again. The momentum before is equal to the momentum afterwards. That means the momentum of object 1 before plus the momentum of object 2 before has got to be equal to the momentum of object 1 afterwards plus the momentum of object 2 afterwards. And plugging in for each of those, we would expand it out to get this. So now we can plug in for all of these values here. Object 1 is going 10, or it has a mass of 10 kilograms. It's going 6 meters per second. Object 2 has a mass of 3 kilograms. It's going 3 meters per second. Afterwards, object 1, still 10 kilograms, but we don't know its velocity. And then mass 2 is 3 kilograms, and we know it's going 9 meters per second. So sometimes I almost skip down to this step and start to do some of these in my head. Like, so you could have seen, since momentum's just mass times velocity, that this thing's got a momentum of 60 in the beginning. This object here, object 2's got a momentum of 9, 3 times 3 in the beginning. So overall, in the beginning, we've got a momentum of 69. That means in the end, we have to have a momentum of 69. This one now has a momentum of 27, object 2. So you can start to do the algebra boxed in right here. Or again, I start to think like, okay, we had 69 before, we have to have 69 afterwards. We've already got 27 from that. So if you subtract that over, you wind up that we still need 42 units of momentum out of object 1. And so when you go to solve for that, I'll do it over here, you get velocity of object 1 would be 42 divided by 10, so that's easy to do, 4.2 meters per second there. One more example here, because this one's got something a little bit different. This is number 5. And so on number 5, the reason I wanted to show you this is the negatives, the left velocity here. So same thing as before. So in fact, this time I'm just going to skip to mass 1 times velocity 1 plus mass 2 times velocity 2 is equal to mass 1 times velocity 1 prime plus mass 2 times velocity 2 prime. Conservation of momentum for two objects. So it's plugging in for these. Mass of object 1 is 3. It's going 3 meters per second. Mass of object 2 is 2. Careful here, this will cause you to mess up otherwise. It's going to the left at 2 meters per second, so that must be plugged in as a negative 2. That's got to be equal to the mass of object 1 times its velocity afterwards, which is what we are actually looking for in this problem. And then we'll add the momentum of object 2 afterwards, which is 2, its mass, times its velocity of 4. Notice, before we even finish this problem, that this velocity, they show you in the picture that it's going to the left. So it must have a negative come out as the answer. So object 1, if you just look at this, is a momentum of 9 beforehand. Object 2, because it's going to the left, 2 times 2 is 4, but it's negative 4. So overall, before the collision, we had a momentum of 5 for our whole system. That means afterwards, over here, our total momentum of the system has to be 5. So we've got some momentum of object 1 here. 2 times 4 is 8. So I sort of think about it this way. How are we going to get to 5? And we already have a momentum of 8. Well, this must have a momentum of negative 3. We can see that. But if I do the algebra and subtract it over here, I get negative 3, subtracting the 8 to that side is equal to 3 times velocity 1 prime. So object 1 must be going, and this is very important, negative 1 meter per second in order to get a total momentum of negative 3 and get us back to a total momentum of 5. A few more things to keep in mind. On some of those problems, like 7, 9, and 10, there's speeds given to you in centimeters per second. So watch that. You'll have to change those to meters per second. That's easy. Let me just give you an example here. If you had 87 centimeters per second, just move it 2 decimal places to the right. That's 0.87 meters per second. Sorry, I didn't write those problems. Not trying to pass the buck there, but that's how they wrote them. And then pay attention on numbers 7 and 8, because those do this combining of the masses. So like if some football player runs and tackles another one and they move off together, or you drop a brick in a cart and they move off together, anytime the objects basically join together, you do this combining of the masses trick that we learned there.